Okay, welcome. Les, this is, forgot, is it like week 6 or something, isn't it? You don't know either. So nobody, yeah, we're just, I know it's about 2 weeks away from spring break though, right?
That's what
we got. We got the countdown there. So in 2 weeks we got spring break, which is great. So we're in the lesson, or unit, we're in chapter 12, whatever unit that is. I think it's 5. But, so we did 8, we did 9, 10, and 11 last week. So yes, this is unit 5 in chapter 12, where we're going to look at the normal curve. And this will be the last part of statistics we'll look at. I have a normal curve calculator in the MAT141, so we'll take a look at how to use that. Also, I got realizing what I'm going to try to do is leave enough time so that we can actually work through all of the reading quiz questions during class. So that'll be recorded, because occasionally there's something in there that I didn't cover in class, because I use older PowerPoints, and anyway, we'll make sure that everything at least gets covered. And the reading quizzes are basically the sort of the minimal things that you would need to do in the homework. Okay, so we'll try to do that. What I'll do is I'll go back and look at the previous reading quizzes, and I'll work problems for those, and I'll post those videos so you can just kind of see them. And if you haven't done the reading quizzes, just watch the videos. They won't necessarily give you the same answers, because your reading quizzes may be slightly different, but they'll tell you how to work through it. There'll be enough where you should be able to go through those. And remember, the reading quizzes constitute about either 2 or 3 points. I think I'm going to up it to 3. I think 2 points isn't quite enough, so we'll give you 3 points of extra credit. I do have to go back through, the way I do it is I export everything into an Excel spreadsheet. There's some formulas in there. They assign the points, and then it gets uploaded into Canvas. And I've been contacted the last 2 weeks, and I keep saying I'm going to get to it. I haven't. This weekend I'll get to it. I'll make sure that those are updated, because some of you are doing all the work, so you should have all the full points plus some extra credit, and those aren't showing up yet. So it's in the formulas. I'll get those updated, and so scores will be on track.
I have something showing with extra credit. Some of
Good.
Them,
some of them do.
At 15, I got 22 out of 15. So I don't know if that's like just all being calculated in that one score, all the extra credit, which is fine.
It shouldn't be, but
because that's a lot of extra credit points,
yeah.
7. So I'm thinking that it was.
Yeah, and it could be know. I changed scoring from 15 to 20 to 20 to 50. So I'll make sure. Okay. So it'll all come out in the wash, and
yeah, I'm not worried about it.
The other thing is, a few of you, and again, we're talking to people online as well. Some of you are getting concerned. There's some people who haven't done much work. What I also teach this as an online class in the fall, as an 8-week online. So if you've done anything, you're ahead of that schedule. So even if you just started doing things after spring break, you've got 8 weeks. You could do 2 a week, and you'll be fine. Okay, so don't get overly concerned, but at the same time, if you can work it into your schedule now, let's make it happen. If you've got a lot of issues, a lot of times take the time to solve those issues, and then when you come back, you'll be in a better state, rather than trying to do math and this, too many balls in the air, you drop everything, right?
Oh, yeah.
So sometimes it's okay to drop math class for a little bit, knowing that you'll be able to come back and pick it up. And even if you stay on track, you'll be done with this class actually early, 2 or 3 weeks. So that's what the schedule's getting us through all of this stuff, with 2 to 3 weeks to spare. So again, you never really are behind, because you'll never lose points. There's no late penalties. There's no due date. So any other questions? Yes.
So since we are probably, if we're staying on top of things, going to finish 2 or 3 weeks early, I know we have like a final exam scheduled day. Will we be able to get the final exam review from you, or through you some way, and then take the test early at the testing center if you wanted, or something?
Exactly.
Okay.
By spring break, I'll actually post the review, because there's some people over spring break, I got nothing else to do. Sorry for you. I'm in that boat too. I'm just staying home and doing work.
Well, yeah, me too.
But so some people will take spring break, and they'll get the 2 or 3 or 4 done, and yeah, they might be ready. So by spring break, I'll actually post the review for the final exam, so you can start to see what's in there. And yes, it's somewhat of a self-paced. Again, we'll have these videos that you can always go back and review. So even if you were just starting today or starting after spring break, you could still see what the class things are as far as the live streams, and that's hopefully they're valuable for folks who missed class, or even if you were in class but you wanted to come back and review it. I hope you're finding them of some value.
Yes.
And again, sometimes, you know, it's like if you're going to watch a TV show, I find it's better to record it, because then you can fast forward through the commercials, right?
Right.
So if you watch the class after it's been recorded, you can fast forward through the boring parts. You don't have to listen to my not so funny jokes or something. Whatever you need to fast forward, you can do that. So that's my goal with this. Okay. So let's go ahead, and I'm going to switch over. Let's see, which one am I going to do? We're going to go to the board. Of course, you didn't know that I was just doing this. So now we've got this, and we're going to go into our class, MAT141, with a student view. So I'm making sure that if that you can see everything I can see here. So we're going to talk about the normal distribution. There is a textbook, so I'll open that up just to, again, this sort of has the background information that I kind of expect that you either looked at or will look at, but maybe not necessarily read. But there are some important boxes where it does bring out some of the information. Okay, and notice we're working with a curve that is symmetric. 50% of the data is below, 50% is above, and this is based on sort of a frequency table. So the bottom is the data, the measurement, whatever it is, maybe size of potatoes, and the Y, or the up and down, is the percent as a sort of the frequency. So we'll talk about these. Anyway, all these concepts are covered in the PowerPoint. In fact, even some of these I have taken screenshot. I think I took a screenshot of this. This is an important concept. And those numbers, 68%, 95%, 99.7%, are kind of important. And they are because they are. It comes from people doing a lot of research and saying that's what happens when you have a normal curve. If you don't have that happening, then you don't have a normal curve, and then you do some other kind of stuff with it, which we won't talk about. We're just talking about a limited amount of stuff. But there's a whole other world of statistics to deal with distributions that are not symmetric. I think it's called a chi-squared or something. I didn't have a lot of fun with it. So, but again, if you get into statistics, those are the things you'll be doing. So this will be one of our slides as well. So a lot of this stuff you'll see, but do take advantage of the textbook. It's here for us, and it's got some valuable stuff in there. Okay. There's some instructional videos. Again, these are me working through the practice problems, so hopefully you don't, you know, and again, sometimes, I don't know, some people might just be joining in at a particular time, so I want to let you know where all the resources are. And it appears I did most of the, well, actually I did 1 through 4, and then I jumped to 6 and 7 through 9. So I jump around a bit. I'm always willing to go back, and you see there's the picture of from the textbook in there. So in these videos I explained a lot of the concepts, and these are from the practice problems in the book, and you'll see that a lot of the online homework were taken from these practice problems. So oftentimes something you might be having difficulties with is going to be explained in here. Okay, and I'll keep updating the videos, because I've also got the one of in the normal. So this is our class presentation. I'll come back to it. Problem solving, PowerPoint. This has a lot of the problems in it. I don't know if we'll see, what is that. I don't even know what it is. I've got stuff in here I don't even know anymore. I'm thinking this one might be mine, because what I did when I did the videos, I actually made a PowerPoint of all the problems, and then I put the solutions in there. Shoot, it's not gonna. Let's see. Whatever. Just wanted some kind of power. Let's see what's in here. So this one is, I guess, just a lot of problems in here. So maybe I used it, but I don't know if it'll be helpful or not. We'll go for the class presentation one. I'm going to open up this one because we will be using it when we get to the when we go through some of the reading quiz questions. And I'll show you how to use this. It's really nice because basically it does all the work for you. We're going to explain how all these things can be calculated by hand. The TI calculator actually has these built into it. It's just a little more difficult to learn how to use. So I haven't even learned how to use it, but I'd be happy to try to figure out how it works. But this is so much easier. You plug it in, and it gives you the graph. That's what I like about this. This is going to give you a graphical explanation of the answer as well. And all you have to do is choose whether you're above, below, between, and outside. On the TI calculator, that's like 5 steps to come up with this stuff. This one, you just click a button, you get a picture, and it sort of makes sense. Okay, and you'll see we'll be using this. When you take the final exam, I think there's 1 or 2 questions that deal with this. You'll be able to use this on the final exam as well. So, we got that, The only thing we need now, then we'll get into the reading quiz at the end. Then you'll be ready for the homework. So we're going to go into the normal class presentation, and hopefully my first slide will work. Occasionally, I had a video downloaded in there, and let's see if it's in there. Wow, it's pretty short.
Well, that means it's easy, right?
It is.
Okay.
It's actually very easy, very simplistic. Let me pull up my video. Where's my video? You need to see the video.
I don't think I
It might be in Canvas, but I'll just, let's pull up a random YouTube video. So we'll just go to YouTube. And we're going to search on normal curve probability. These are just all problems. What I want, there's a demonstration. Here it goes. Something like this. So let's see if this will. Now they've got a lot of these. Basically, the normal curve works the way it does because as you look at this video, we pour things down, and each of these nails or something, there's a 50-50 chance it could go to the left or the right. And there's a bunch of 50-50 chances. What ends up happening is, let's go ahead and make this large screen. There we go. Is that there are, as you see, there's a pile up here in the middle. And there's less as we go further out. This one has sort of a no ends, and they just bounce out of there. But if you watch these, this is they have a formal name for this because it's how they studied it. But this is where the normal distribution comes from, is when you have something that is made up of a lot of different components, which this is, right? Because you get down here, again, it's just a 50% chance going one way or the other. This is what naturally sort of happens, just based on random probabilities. There are a lot of things in this world that are sort of based on something like this. And again, they do, it's not always perfectly, because again, it is probability, but if you did this enough times, you typically will get a normal curve. So things like genetics have an effect, are generally distributed by the normal curve, because there's a number of things that go into making a human being. We've got how many? Does anyone know how many genomes or how many? Well, we got chromosomes, right? 46 chromosomes, and they're paired up, and then those have, I don't know how many gene mark. Anyone into genetics? Me neither, but there's a lot. So, but does that that kind of get to the understanding. Oh, it's called a Galton board. Galton board, something. And again, you could just. I just remember when I was a kid, I went to this place called OMSI, the Oregon Museum of Science and Industry. It's up from Oregon. And they had one of these things. And everyone else was going around the museum. I just stayed for like 2 hours and looked at this thing because it had sand coming down, and I just wanted to see it fill up. Simple things, simple pleasures, right? But you see, it's a probability. So everything we're going to do today it just happens because it happens. Yes.
Well, I do find it unusual though that they don't put the entrance to the top at a different place. They only put it in the middle because that does decipher the probability of where it is.
Exactly. Yeah.
So that's
if we change that, then we
right,
would get different.
It would.
Yeah. So this is things that sort of always have a similar type place that we're starting with, and again, for humans, But it doesn't matter whether it's on this side or this side. It's always going to be the middle will get wherever it's pouring out.
I get it.
The middle will get the most.
I get it.
Again, because that's the 50-50 chances are that it's going to go left, right, and drop in the center. So we just, So you watch these a number of times, and again, one of them I had a nice guy from Australia. I liked it because of his accent, but he explains it also. So you might do a little bit more searching, but it's just, there's more probability that they will land in the center than anywhere else. And you could probably make different boards with different probabilities and get different results. But
that's the standard.
Yeah. Oh, this guy. Good. We just waited long enough. Let's see if I can get some sound out of him. Oops. Well, this is the video. Let's see. Bless you.
So each path is pretty much unpredictable. If I was to take 2 balls and put them in, even if I try and put them in exactly the same, they will end up in completely different positions. We cannot accurately predict where any given ball will go. However, we can make a few statements. We can say that a ball is more likely to end up in the middle than the edge, because the center categories, there are lots of different paths that end up here. There are only a few paths that end up on the edge. So what we can do is take this piece of scientific equipment, attach it to the top, and start putting these in by the handful. If we put in absolutely loads of these balls, even though each individual one we couldn't accurately predict where it's going to end up, we can accurately predict the overall pattern from lots of them. Right, and that pattern we end up with is called the normal distribution. In fact, we've got a few too many in the middle there. Now, a lot of things in nature follow this pattern. If you measure people's height, they will follow a normal distribution. Shoe sizes, a lot of things in science and engineering and maths match this kind of bell-shaped curve. In fact, those of you, if you've done A-level maths, you will know that because the ball has choices of going left or right on each one, this is actually a binomial distribution. And if you have lots and lots of balls going down, as you get more and more of them, it gets closer and closer to exactly matching the normal distribution. So there you are. In probability, you can't predict the exact location one ball will end up, but you can say a lot about what will happen across many balls.
So when you say in binomial, that means there was the two ones with the most in it, because there was 2.
You have 2 choices. You can go to the left or the right.
Oh,
that's
okay.
bimodal.
Oh, okay.
So there are things. In a chromosome, you get either one from your mom or one from your dad. So it's a 50, each one, but it's a lot of 50-50 choices. Okay. The thing is, it's the hardest part of this whole thing is I'm going to tell you like 68% are between 1 standard deviation above and below. And people say, well, why 68? And I go back to this video because of this.
Right.
It just is because it is. And people want some kind of explanation. probability. It just is because it is. It's 68% because it's 68%. Okay, so they measured it this way, and if it's not 68%, it's because it's something else is going on. Okay, and the thing is we use this heavily when we do research to figure out whether the treatment that we're applying, or the drug, or whatever it is we're doing, that it's having an effect beyond random probabilities. Because it might make a change, but we have to say, is it significant enough a change that it, because probability says it, it could be here, left, or right a little bit. But if it's a big enough difference, then we can say it was the treatment that caused the difference, not just randomness. That's what all of research is really based on, is to show that it's not random chance that's causing the changes. Because sometimes random chances do cause a change. Okay, so let's go ahead and start off. I've got a class. What did I do? I downloaded this, took a look at it, and let's go with a slideshow. And we will do it in a window so I can control the size. Click at the start, and I'll make it a little bit bigger. Okay, so today's really is just the normal distribution. It's a few simple concepts. I don't like using the word simple because when you don't understand something that's simple, then you think, well, what's going on? But it's usually we don't understand the simple things because we're trying to make it more than it is. So that's why, I mean, it's simple, not that it's easy to understand, but once we understand it, we say, oh, I was overthinking it. Okay, so we've got a normal distribution. Again, what is a normal distribution? Well, a little bit of review is that what we talked about last week. Does this look familiar to anybody? Hopefully it should. Blue. So here's our types of distribution. And again, remember, the up arrow is frequency. It's how many times something happens. And along here is some sort of a measurement, data values. Might be a salary, so this is our salaries going up, and this is our company, the distribution of salaries within a company. Most people are making the salary in the middle, whatever that is. They also can do it with time series stuff like stock prices and stuff, but what we're going to focus on is this sort of one today. There's also a double peak, so when they call this bimodal, and again, we could look at this as two separate distributions, and then they sort of both are normal if we cut them in half, maybe like, oops. It's one of those weird things. I look at it and I go the wrong way. But if we cut it into two different ones, we could analyze each maybe as a normal curve, but together they're not normal because they have, it's a two-peak distribution. Okay? Let's clear the window. Go to the next one. The other part is that this idea of symmetry or being skewed. Now, for a normal curve has to be symmetric. If it's not symmetric, it's not normal. Okay? So our curves are going to be symmetric. 50% will be below the mean, and the mean, median, and mode are all the same value. That's what also happens when we have a normal curve. If this doesn't happen, then it's not normal. And we use other techniques. 50% above or below, 50% above. So half above, half below. It's symmetric. Okay. This is when we're talking normal curve. Symmetric is the normal curve. If they're skewed, which means the mean, median, and mode are not the same, we have outliers, either low or high. It's not normal, and that's not going to be part of what we're going to talk about. And when I use the word normal, I'm using it in a technical sense for a math distribution. It's not the English mean that normal is average or ordinary. Normal is a particular type of distribution we're going to talk about. We should call it something else like Fred or something. It might make it easier to understand. Okay. But they named it the normal curve. Okay. So I guess I could take some pictures as I go, but there. So clear out the screens. This is just kind of the setup. Variation. Again, we could have things with low, moderate, or high variation. What we're going to do with the normal curve is the normal curve will be manipulated a little bit, but we're going to standardize the variation. So it's going to have a standard variation, which is mentioned down here at the bottom. Right. So the normal curve has standardized variation. And what that means is we force it to look a certain way, so it'll look more probably like this moderate variation here. You're going to see a single peak and coming down. Let's see what happens with the next one. Variation describes how widely data values are spread out about the center of a distribution. And again, for the normal curve, which we're talking about this time, we standardize it. And there's a formula that we use to standardize it all. Take advantage of that. Oh, there's my videos. So they're in here. So if you download the video, you can see that one again. That was the guy weighing potatoes. Oh, there was another video. It's kind of cool. He's actually taking potatoes. He weighs them and then puts them in the part of the normal curve, and you see that you get the normal curve out of it. So it's about a 2 or 3 minute video. Take a look at it. Again, it will help you understand why 68%, 95%, 99.5%, I forget, but we'll see. Those values are going to be used throughout the homework. Why are those 3 values what they are? Because they are. It just happens. It's nature. Okay. So here's the number. This is 99.7. In fact, I had one student who went ahead and did this, and she got an answer that was 99.72. She entered it in and said it was wrong, and she says, but that's what my calculator said. And her calculator, I would say, probably was right. It's just that when we're talking of these are empirical values. These are not necessarily exact. Like if you were to actually calculate the 68%, it's more like 67.94 or something. It's not exact, but who's going to remember some decimal quick? So they've kind of rounded these numbers. But when they ask questions that use the rule, or the empirical rule they call it, your answer will be one of these 3 numbers, or we're going to see it could be half of them. Okay. So what happens is this is a standardized normal curve. Okay. And we'll go through this is where it's going to be helpful. We'll go through the reading quiz questions, and it will actually help explain a little bit this. So when we calculate things, what we do is we have a formula, which we'll see in a little bit, but it makes the mean become 0. And then it makes whatever 1 standard deviation above to be 1 standard deviation, 2 standard deviations, and 3. Okay. And then when we go below, we get 1 standard deviation below, 2 below, and 3 below. Okay. We're going to call these, are referred to as z-scores. Okay, so these are z-scores. And we'll talk about how to calculate. But it just so happens that when you have a z-score that is between -1 and 1, you actually got 2 z-scores, and that says that 68% of your data will be contained between -1 to 1. 68. Again, why? Because it is. Okay. If your score is between -2 to 2, 95% of your data is going to be contained there. Go here. This is -1 to 1. And then if you're from -3 to +3, I should put the word 2. you're going to have 99.7. We'll work through some problems, but these are values that are going to come up. Because what we want to do is we want to calculate, if I've got these two data values, this one and this one, what's the percent that I would expect to be between that? What's the percent results? So the thing is when I do research, if I get results that are like way outside of that, I could say it's not due to probability. If I get results within these percentages, I say, well, that's just what would happen anyway. It's a daily variation. Some people are tall, some people are shorter, some people are in the middle. So we get these variations normally. And if you look at a group of people, especially ones that have maybe been isolated and genetically isolated, they tend to be closer to each other than others. So that's why you get some groups of people who are a certain height. They're all 5 foot, or they're right at that. And then you get a certain group. You look in Africa, some of the tribes are very, very tall. They got a lot of tall people. And again, because they have their genetics have worked that way, and they've been isolated, they haven't intermarried with other groups. Okay. But there is variation. Questions so far? Don't even know what to ask, right?
No.
Not yet.
Not yet.
Because we haven't really done anything, but now this is where we're going to explain. So this is sort of an explanation. And again, we only have a few more slides, and then we'll look at examples. And by doing the examples, we'll sort of see how it works. And what I found is some of the best examples are right there in the reading quiz. Well, actually, they've got it set up nicely so that we'll learn from it. Okay, so this is how we get a z-score. We take a data value. We subtract the mean from it. So remember, how do we get the mean? What's that? Well, it will become 0, but we'll show you how this works. But how do I get the mean? The mean might not, it doesn't necessarily start off at 0. Like, say I have a bunch of potatoes, and I weigh them. I want the weight of the average weight of the potatoes. How would I get the average weight of the potatoes? Well, I would take each of the weights. Say I've got one that's, I don't know, 10 ounces. I got another potato that's 12 ounces. And let's say I've got a 13-ounce potato. So only 3 potatoes. How do I figure out what the average weight of the potatoes is? I add them together and divide by 3. Should show some better values. That's 15, that's 20, no, that's 25, 35. 35 divided by 3 is going to be like 11.6
or 11.7.
Or 7, yeah, something like that. Or 6, 7.
Yeah, there you go.
So that's now our mean potato. What that does is that goes right here. If I take a 4th potato, so let's say I have all my potatoes, I want to calculate the z-score. Let's just say what would the z-score be of this 12? I take the data value, which in this case might be 12, subtract the mean from it, 11.67, and then I divide by the standard deviation. Now, how do I calculate the standard deviation? That's from 11. It was that big messy thing, right? Take each of the data values, subtract the mean from them, I square that, I add them together, I divide by something less, one less than that, and then I take a square root. Or I just plug it in the calculator and it gives it to me, right? Cool part about it, yeah. The cool part about it is in this chapter, we don't have to calculate it, they will give it to us. So they'll just tell us it's a given. In fact, actually, they don't give us all the data. They will give us both the mean and they will also give us the standard deviation. So let's say they told us the standard deviation was 3 ounces, 3 ounces above or below. So our calculation would look something like this. We take 12 minus the mean, and then we would divide by 3. And that gives us something called the z-score. Notice if the the weight of the potato that we had was actually the mean, we'd get 11.67 minus 11.67, which is 0. 0 divided by 3 is 0. So that's why the mean always will become 0. Because if we've got something that weighs the value of the mean, we subtract the mean from it, we get 0. Okay? So that's how we standardize it, and we're going to look how to do it. So let's walk through one more example.
Can I ask a question on that?
Sure.
Because the mean is the minimum, right?
No, the mean
Okay,
is the average. And so the
Okay,
we
why
add
get the mean and the medium confused? Because I think
yeah, the mean,
the average is the mean and the medium is just the middle.
the middle, exactly.
Okay. Okay.
Yes,
Okay.
good.
So the mean, which is the average,
Yes,
can also sometimes be the same as the data value.
it could be. We could have one that is
The
actually the
average
same.
could be
Yeah,
the same as the data value. Okay.
yeah,
I mean, all right.
yeah. It can
I've
be.
come across that. I will
Yes.
talk to you.
Okay.
What's the benefit of going through this formula if we always know the answer is going to be 0?
It is only going to be 0 for the value of the mean. If the weight of the potato is not the mean 11.6, then it will be something other. And in this case, it'll be positive. We can see 12 is a little bit above. This is going to be what, 0.33, or pretty close to 0.33 over 3. And so what it ends up being is 0.11. And we're going to show that we use the z-value to figure out what percentage of scores are either above it or below it. Okay, and then we can kind of compare to see, if we used a new fertilizer, maybe we're getting bigger potatoes, or maybe it might be something else. So we get these other values, and those are the ones that are going to be useful. Okay, so let's walk through. I think I can just leave all this here. This slide will actually get us to walk through a calculation. So, an example, the national ACT. Anyone take the ACT?
No, what is that?
It's some college
test.
test. I took the
Okay.
SATs because that's on the West Coast they all do that. I guess on the East Coast they usually take the ACT, and here in the middle you maybe take one or the other. But if going from high school to college, usually you take either the SAT or the ACT. Okay, they are scores that are the scores on the SAT and the ACT are normal. However, they have been forced to be normal because what they do is each year they look at the results. And if too many students get a question right, what do?
Take it out or change it?
They take it out or make it harder so not as many students. If not enough students get a question right, nobody got it right, they say that's not a good question, so we'll either make it easier or take it out. They manipulate the questions until they get a normal curve.
Okay.
So this is one of those things in education. We think everything in education is a normal curve, but it's been oftentimes manipulated to become a normal curve. And so as we get smarter, it's not that, okay, we're all above the mean now. The mean keeps moving. And so it's like, I don't know. It's a conception that kind of keeps some people below and some people above. So don't ever, everyone gets all up in, we're below the mean. Well, somebody's got, 50%'s got to be below the mean if we're going to keep things normal. It's normal for half of our people to be below the mean. In fact, if they weren't, then it wouldn't be normal, okay? So, I don't know, maybe we don't want to be at the bottom, but, okay, so these are the types of questions. They give you, oops, what happened?
Uh-oh.
I just went through the whole presentation in an instant. Did you catch it all? Maybe not. So we'll come back here. Let's go back to this slide. There we go. So what I want to do is switch to the pen again. So this is a typical story. They have a mean, so they give it to you here. You don't have to calculate it. They just tell you the mean is 21. And they give you the standard deviation. Again, they did the calculation on the data they had is 4.7. Then we need to find the z-score for a score of 30. So we took the test and say we got a score of 30. What does that mean? Well, it means that we have a z-score, that's the data value, 30. We subtract from it the mean, which they gave us up here. and then we divide by the standard deviation. 30 minus 21 is a positive 9. Positive 9 divided by 4.7. It's like
25.53.
9
Or did I? Oh, okay. So
divided by 4.
9 divided by 4.9. Okay, now I lost you. What is that one?
Should be like 1.9 something.
It's 1.83.
83.
Or 1.84.
84 if we round it. So that's our z value.
Okay.
And I'm going to show you how we'll use this. We'll see that that means, what that is sort of saying is that our score of 30 is almost 2 standard deviations above the mean. See, 1.84, this is measuring in standard deviations. I'm almost 2 standard deviations above the mean. And if you remember that chart, is that a good score? Yeah, that's pretty good.
It's pretty good.
And we're going to turn it into a percentile, which is what percent above. Okay, so let's go here. The slide also does the calculation for us. Bless you.
So is it always going to give us the
Should be.
find the z-score for a 30? Is it always going to say find the z-score for a, or is it going to not?
They'll change
sometime?
that. Yeah, 30 will
Okay.
be changed. They'll give us
But
different data values.
That's what I mean, but they're always going to give us find the z-score
Yes.
for this,
Right.
for this, for
Yeah.
this. Okay.
We'll come across a couple where they'll give us a z-score and they want us to go backwards, do a little bit of algebra to find the data value. We can do that as well.
Okay.
But they will always give us the mean and the standard deviation. Chapter 11 is where you had to calculate some of those. Chapter 12 is where they will give it to you, okay? Because that's all they want you to do. Now, if you're doing a research study, you would do the whole thing. You would take your data, you would calculate the mean and the standard deviation, and then you would examine how does it fit in a normal curve or other things with it, okay? So it looks like, did I do the calculation right? It should have been 1.91. So 30 minus 21, that is 9, isn't it? Sometimes my math gets off.
Yes.
And then 4.7, oh, I put 4.9, that's where it was 4.7 there, and I somehow changed it to 4.9.
Oh, okay, that's what, okay,
So
that's
I threw you
okay.
off. So let's come back, let's fix this up.
1.91.
1.91. Okay, so now we match.
Okay, I want to just go clearly. Okay, find the z-score for a 30. I'm a little not understanding what the 30 is. What is it?
It's a score. That's what they scored on the test.
It's a standard score.
No, it's just they took the test
Oh, a score.
and you got a score of
okay,
30.
so one person got a 30. Okay,
Someone got
so
a 30.
I just want to know what to call it if I'm actually writing out z equals something minus mean divided by standard deviation.
So call that the data
it's
value.
Data value. Thank you. Okay,
Data
there
value.
it is. I'm gonna write it out just so that
Yeah.
I have it. Okay, thank you.
Okay. And again, we'll go through. We're almost done. I got I think just 2 more slides, and then we've got plenty of time to go through the reading quiz problems. And I think that's where it will
Click.
really click.
Okay.
Okay. This is just it's not a lot, but it's just kind of like it throws you at you, and then you just have to accept all this stuff that doesn't really make a lot of sense until we start working with it. Okay, so we'll take a screenshot of this. Now that it's fixed. Page 3. There we go. Clear the screen. Remember that 1.91. And this is where we use it. So this gives us a percentile. So if it is normally distributed, which is an assumption, what we do is we take that z-score that we got. And again, what we just calculated was 1.91 for that particular 30 score of 30, right? So ACT score of 30 equals a z of 1.91. What we do is we use that to look at the z-score. So notice these are negatives, and I'll show you one thing that should make sense. If we had a z-score of 0, we're at the mean, right? Z-score of 0 is the mean. We have exactly the mean score of, I think it was 21. Notice our percentile is 50%. That means if we got a z-score of 0, we scored better than 50% of the people. Percentile means percent better than, or percent. The 50% scored less than us. If we scored the 30, since it's got a z-score of 1.9, we keep going, right? Here's a score of 1.9. They don't have 1.91. What percent of the people did we score better than? We're in the 97.13 percentile, which means we scored better than 97% of the people who took the test. Did we do good? Well, if we were comparing to other people, but we're unique. We don't have to compare to others.
Right.
We're in the top 3%. Okay, so that's what you could say.
That's because it's the
Yeah, so yeah, percentiles are,
top
remember,
3%,
we're always dealing out of 100,
97.
so
Yep.
we're in the top 3%. I remember when I was probably elementary school or something, they did this thing, and I got in the 10th percentile. For some reason, I thought that I was in the top 10%, so I was bragging about being in the 10th percentile. My dad got me home and says, son, you might not want to be bragging about that. That's the bottom 10, not the top 10. I said, oh, whatever. Who cares?
Who cares?
10%.
It's 10.
I'm in the top 10%. That was my thinking. Grew into it. I wasn't going to accept that I was in the bottom 10, but so what? But that's when they're saying percentile. You want to be in the higher percent, or the percentile is percent below. Okay, so percentile has the I. So I say you're in the 60th percentile. That means 60% are below you, 40% are above you. So this is where the probabilities sort of come in again. This idea of above and below, and that we're still dealing with 100%, right? Everything's 100%. So you have this chart, and again, you see as you get closer to like a 3.5, so that's 3.5 standard deviations above the mean. We got almost all the data. That's 99.98%. So if you scored above that, you're really doing, really good. Okay. But again, it's all about some of these tests. I don't know. They're about sorting people and saying you're above in this. It's not really about mastery learning. And again, remember, all these tests are designed to sort people out. And if everybody starts doing better, they change the test so that the bottom half can never become the top half. Because as soon as you become the top half, they change the test, and now you're at the bottom. There's always going to be, with this kind of mentality, there's always going to be 50% of the people who are below the average. 50% are below average, 50% are above average. And so we've got a world, this is creating a world, especially when it's a created thing. Now, if it naturally occurs, it naturally occurs. Okay? But when it's created, and oftentimes in education, it is a created thing. Grades are created. Some people say, well, you're giving too many A's, so that's, devaluating it. Well, maybe everybody is mastering at that level of an A. Why can't everybody get an A? Right? It's about us individually mastering. And that gets me to the other point is education, is it a random act? I hope not. I hope I'm getting paid some money, not because I just randomly talk here and you randomly learn something. I hope I'm guiding you along a path that leads to success. And if that success is an A, why not all of you? Why can't I get a path that leads all of you to an A? Why only 50% of you can be above a C and 50% of you have to fail? That was one of the mentalities of this world. Half the people have to fail. Why?
Right.
Why can't we
All
make it?
succeed.
And the cool part is I'm going to click on the next slide and watch. I think we're done. I don't know if that's cool or not, but it means we're done with this stuff. So now what we're going to do is we're going to look at the reading quiz problems. We'll work through some of these together, and you'll see how it really just kind of, this is the only concept. The only formula you need is that Z formula. Again, they're going to give you the mean. They're going to give you the standard deviation. One of the things is as you're working with these, you probably don't have a good intuitive feel of what those things are. But what does the measure of the mean give us in general? If I've got a bunch of data, Where is the mean?
The average.
It's the average, so it's somewhere, it's kind of getting at where the middle is, so it's a value of the middle. What does the standard deviation try to measure or give me? How far away from that mean I am. So it's not the standard deviation, we don't want to think of as a single point. It's a relationship to the middle, how far away from the middle the data is spread out, whether it's widely spread or not. So the bigger the number of a standard deviation, that just means it's more spread out. A small number for the standard deviation means the data is not as spread out. The mean, though, gives us a measure of where is the average or the middle piece. And if you just get those things down, that's really all you need for this part. So let's clear off the screen. Let's go ahead and close this window out, because we don't need this anymore. Don't need this. That's for this one. Oops. One way or another it works. Okay, so where we're going to go? We're going to go into the reading quiz. I don't know. We'll come back to this. I think starting off with these wordy problems,
We're still learning.
yeah, we'll learn the concepts and then we come back to them. That's the way I kind of do it.
That
So,
makes some more sense.
okay. So let me also, while we're at it, see if I can do this. Make the click here. Maybe this one. Make the window a little bit bigger. Is that better? Easier to see? Okay. And actually, go one more step. Okay. So for these ones, what we're going to be asked to do, the time to complete an exam is approximately normal with a mean of 51 minutes and a standard deviation of 5 minutes. Okay, so we've got these two numbers. What we want to do is come up with a normal curve here, basically using the z-score calculator. The bell curve below represents the distribution for testing times. The scale on the horizontal axis is equal to the standard deviation. Fill in the indicated boxes. So this one's actually, we're not going to calculate z-scores, sorry. But what is the mean, and where does it go?
51.
The mean is 51, and it goes in the middle.
I don't know. I think a medium goes in the middle, right? So I don't know.
Well, does anyone recognize this symbol? It's probably in the textbook. It's a Greek letter. It's called mu.
What is it?
Mu, whatever, mu.
Okay.
So it's written like this, sort of. It's a Greek letter. And it's called mu, but they use it to stand for in math the mean. So when you see that letter, just think that's the mean. So when you see this letter here, that tells you the mean 51 goes in this box.
Okay.
Okay, so what I'll do is I'll actually put the numbers in here and we'll click on the buttons. So 51 goes here. Now what do you see happening here? Okay, so another Greek letter. This is the hardest part of the whole thing, the Greek letters. That's a little Greek letter called sigma. You've heard of sigma before?
No. If I have, I don't remember.
Well, if you, I didn't join a fraternity, but that's if you go to universities, a lot of times they have fraternity row and or sorority row, and sigma is one of the letters because it's a Greek society.
I'm
So
thinking
yeah,
math
and yeah, in math, we also use the
Okay.
sigma. Another thing you may have seen, this is little sigma. Big sigma is this thing, and it gets used for math when you're summing things, when you're adding things together. So that's big sigma, that's little sigma. And in statistics, they use little sigma to stand for the standard deviation. So actually, instead of going back and forth, I'll just write down here. So 51 is the mean, This is just telling us we take the mean plus 1 standard deviation. Standard deviation is 5, so that's 51 plus 5. That should be like 56. And then we're going to add 2 standard deviations, or just add a standard deviation again. So 56 plus 5 should give us 61. And then we add 5 again, going up another standard deviation. 61 plus 5 is 66.
Oh, 66.
Thank you. Okay. And yes, I could figure it out on my own, but sometimes I don't like to. Especially when we go the other way, because we're going to be subtracting, right? So as we go down, we subtract 1 standard deviation each time. Now you could jump to the end and subtract 3 times it, but again, so coming down, we subtract a standard deviation. So that's 46. Is that right? Subtract 5 more. 41. And then subtract 5 more.
I mean, that's 36.
36. And those are the values we put in there. That's all this one's really asking us to do.
So it's actually asking us to calculate it, not just, okay,
Yeah.
pretty much.
See, I'll just put each of those in there.
It
56.
says it's not right.
For what? Because we have different numbers in our computer.
Yeah.
Ours
So
is supposed to be
Oh,
47
gotcha.
and
Yeah.
5, yeah.
be careful, because yeah, that's why I can do these. Because you think, oh, he's doing our homework for us, but I'm really
No,
not.
You're not.
I'm doing the process of
which
the
is
homework.
good.
Yes.
Because, we're always trying to get it done, but
Exactly.
the reality of it is
And I've had
I can
students,
do this
several
now.
of them, but I remember one of my favorites. He's now at ASU, but I had him in multiple classes because all his goal was to get the homework done. I says, but do you remember what you do? He says, no, but I'm done. So then he'd have to take the class again because he'd get people to
Right,
help him
right.
with the homework, which was great. But I says, get help, but understand what you're doing. He said, why? I just need to get done. And then finally, after about the 3rd time, he says, okay, I'll try to learn it. And he did. He did very well. But you need to learn the
Yeah.
processes. So yeah, so we'll let's see. Actually,
I'm just going to follow you. I already tried
Yeah.
to do that.
let's just take a picture of this.
I was like, oh crap.
Yeah.
It's trickery, I tell you.
Oops. Let's do that. Clear this off, and then we'll just click the submit, and hopefully we get it right. Let's see. Submit. Yeah, so we got it right. Okay, so that's one of the things. These are good to go through and practice, but again, you're just putting the mean in the middle, and then you're adding standard deviations, and you're just kind of seeing. So it's really a helpful way of doing it. I think this particular unit is one of the best. And again, this is just same thing, just different numbers.
Okay.
39, and then we add 2.2, 2.2, 2.2, or we subtract 2.2, subtract 2.2, subtract 2.2 repeatedly to get our middle of 39 right here. And we add 2.2, which is 39, 40, 41.2, and so forth and so on. And
Right,
then,
right.
and you won't see them here, so it's not. And then this one is just, we're subtracting 2.2, so that's going to be 37. That's going to be 68.8, I think. And just from 39, so we're subtracting.
Minus 2.2, 36.8.
Yeah. So we'll just put a few notes here. This is the mean. Oh, we got more questions down below, so maybe we better finish it. This is going to be 42.2, and then we're going to add another 2.2, so that'll be 44.4, and another 2.2, that'll be 46.4, and then the other way we're subtracting, so 60, no, not 60, 36.8.
And then 34.6.
So we're subtracting 2.2, and 34.6,
0.6.
and then 32.4.
.4.
Okay, so those would go in the box. Okay. Now this is where, let's see. So far, any questions on that? So we're just taking the mean, adding 2.2 to it 3 times to get the numbers above, subtracting, getting those. Should have moved up first because we're not going to follow.
That's right, we understand.
But okay, 68% of the testing times were between blank minutes and blank minutes.
Is that 36.8 and 40?
Exactly. One below. This is one below. We subtract it 1 time, right?
Right.
So let's see if I can. Oh, there is a way. I figured out I can draw straight lines right here. Line. So I'm going to draw a line from here to here, but yellow doesn't work very well, does it?
No.
No, let's go with dark green. Draw a line from here and to here, and from here and to here. So doesn't that's the 68% is the part in the middle.
It's the -1 to the +1.
Yes. So this area here. So yes, that would be
36.8 to 41.2.
42.2.
39 plus 2.2. Is it 39 plus 2.2?
Yes. Oh, you're right. It's 41.
It's 41.2. I don't know
Good,
what we
thank
did
you.
last time, but
Yeah, I see what I did. I said that sometimes you have to add those answers. Arithmetic error. 41.2. Okay. This one's going to be 43.4. And add to that 45.6. Coming down, we got 36.8. No, 30. 36.8.
Oh yeah.
And this one was 34.6 because we're going to need these, and then 32.
32.4.
Okay.
That one I think is
So the 95%. Here we'll use a slightly different. Let's go ahead and use red. Is 2 standard deviations below to 2 standard deviations above. So from here to here, that's the part where 95% of the data is. Doesn't it look like it? You've got all of this area is 95%. So the score, 34.6 to 43.4. So this is the thing. This is the hardest part of it all, but it's going back and forth between standard scores and data values. So this is a standard score of -2, but a data value of 34.6. Okay. This here is a standard score or a z-score of actually 2, +2, but a data value of 43.4. And I'm just going to, even though the question isn't asking that, I'm going to show you that if I calculate the z-score, 43.4, remember I subtract the mean and I divide by the standard deviation. Someone tell me what is 43.4 minus 39?
I'm trying to figure out something else. 43.4 minus 39 is 4.4.
And you take that divided by 2.2, what do we get?
2.
That's z-score of exactly 2, 2.0, exactly 2. And that's exactly what we've got here, 43.4, 2 standard deviations above.
Why is it the 3 and then the sigma, and the 2 and the sigma,
3 times the sigma, so 3 times the standard deviation. So notice we got to this, we took the mean and we added the standard deviation. We entered the sigma 3 times to get to this.
It was give times 3.
Yeah.
Okay.
And we added the sigma 2 times to get to here.
Okay.
Okay. So yeah, you get to, 1 sigma, 2 sigma, 3 sigmas.
I get it. Okay.
Yeah. Make sense? So far so good?
So far, so good.
Okay, so it's really just, it breaks down to really adding and subtracting. We can use the formula, maybe a little bit of division, but understanding where they are on the graph is kind of the basis of this. And then 99.7, remember that's 3 standard deviations out, so we will go with, what happened? Use violet, why not? So there's not, it looks like, here to here, not much to draw, right? We're 3 standard deviations out, but from here all the way to here, that's what the 99.7% of the data is. So we go another standard deviation. The way to think of it is, look at, we only added a little bit more. We added, what, 4.7% in this little part here. Okay, we picked up 95 plus a little bit more. The further we go out, the fewer data values we're going to find as far as the frequency. Okay. But again, in this case, it's just 32.4 to 45.6. %50 of the testing times were below how many minutes?
39.
Excellent. If we know the mean, we know 50% are below, 50% are above. So that's what these things will work with. It's just, again, you could highlight that with, I guess we used green already. Brown, why not? So we can draw this line here. 50% are below the mean. Okay, so that's just getting to understand that when we use the normal curve. Remember, not everything fits the normal curve, but when data does fit this pattern, this normal curves, we get this powerful mathematical technique. And if it doesn't fit, we make it fit, and then we use it anyway. Okay. Say, okay, half of you are going to fail, and half of you are going to, this is the way the world works. Half of you will get food, and half of you won't. It's really, it's a whole mentality that's out there. I'm not saying it's right. In fact, I'm saying it's wrong, especially when it's forced. But it is a valuable thing for things that actually are normally distributed, like the size of potatoes or whatever. Shoe sizes are normally distributed. There's, so you got big feet. My brother's got, like, one's got a size 14, one's got a 13 and a half. And they'll argue over it because one will wear the other boots, but he stretches them out because he's got bigger feet. But, there are people with very large feet. There's people with smaller feet. We get that variation. It's a normal part of life, and it's diversity. We celebrate that. But we don't necessarily, we shouldn't be trying to make things that aren't normal necessarily fit into the normal curve. Okay? But we can do that when we think of, and again, it's because of how people have thought of intelligence. Okay? So let's take a picture of this, we'll save it, and we're on to page 6. Okay. So it's already saved it, so let's save it again. We'll clear it out, and just kind of keep going. So really, we only got, well, we didn't check it out, but we did 3. We'll do 4 now. Now 4 is going to change. They're giving us data values on here and using the empirical rule to kind of backwards. So this one we can maybe just take a look at. Use the empirical rule to answer the following questions. So if we look up here, what is the mean?
70.
See it right there. Good. So it's just kind of getting you to get comfortable in reading the chart. What is the standard deviation?
70.
Standard deviation. How do we get that?
Just count the number in between each numbers.
Exactly. So you could take 77 minus 70. That's 7. And you can see 77 to 84. So you could take 84 minus 77. That's also 7. So the standard deviation is 7. Good. And again, your chart might be different. Sometimes they aren't, but that's okay. So what percent of the test scores are between 63 and 77?
50%? Oh,
68.
68.
Oh, that's right.
Exactly. So that's
Okay.
from 63.
To 77.
It's kind of like a line there, and 77 would be the line there. So this middle portion, one below to one above, is always the 68%. 68% here. And why? It just is. Just is because it is. That's nature. That's how probability works, remember? 68. Between 56 and 84, so we see the 56 is 2 below, 84 is 2 above, 2 below to 2 above, 95%. Just have the little thing printed out from the book.
We have it memorized now.
Or have it memorized. Yeah, it's just 3 numbers to memorize. But again, it's, let's see, where's the textbook? Oops. It's okay. There's a chart. I'll just show you. Yeah, this thing. You know, take a look at it enough times. You got it. Yeah, just 68, 95. And then the percent of test scores between 49 to 91, 99.7. Now this is where it's going to get a little bit tricky. So just as soon as you figure out how the game works, they change the rules, right?
Always.
Always. But this shouldn't throw you too hard. Percent of the test scores between 70 and 77. 34? How'd you get that?
It's half of 68.
Exactly. So go with the...
Oh.
So from 70 to 77, right? Exactly. It's just cutting this region here, the 68%. Oops, gotta change. And it's cutting the 68% in half. So you're right. There's 34%. So I said you'll be using either 68, 95, or 99.7, or you'll be using half of them. Because sometimes we only have half of the region. We're only the half that's above or the half that's below. Okay, so that's about as complicated as our calculations are really going to get. You either take those numbers or you divide them by a half. So that's going to be 34% of the scores less than 70, 50%, because that's the mean. So you just look. So it's very visual. Look, you have to kind of get used to looking at the normal curve. And when I was learning this stuff the first time, I would always draw this little normal curve. I got good at drawing little normal curves, and then you go half above, half below. And you'll see the calculator we're going to use does the same thing. Let's go up a little bit. The test scores that are less than 77. We have to kind of put two, this actually gets a little more complicated. We have to put two values together, right? So less than 77, well this part here we just figured out, that's 34%. And the part below the mean is how much? 50. I'll put a, should keep on going all the way. There's 50%. So the part below 77 must be 50 plus 34. And that's really all you end up doing with all of this is you figure out areas and you're maybe having to add or subtract them. So that's 84%. And that will go down below. And then let's see, is there anything else? Nope, there's not, but let's take a little picture of what we got here so that the drawings make some sense. Let's clear it off. Let's just plug it in, submit it. See if we got them all right. Good. Pick up a little pace. Consider the standard normal distribution. The mean is always blank and the standard deviation is always what? Standard norm. So once we standardize it, good. It's always going to be 0 in the standard curve. So we change the data value into a z-score of 0. And what is always the standard deviation? 1. Exactly. We make it become 1. And so it's 1 below, 1 above, 2 above, 3. So that's that z-scores. So we standardize it. 0 is the mean, 1 is the standard deviation. And then we get these tables that we can use for any type of data. But what we do is we take all the data values, turn them into standard scores, and then we don't have to get a separate table for each type of data. Okay. I remember the first time I was like, oh, mean is always what? But you have to, it's only for the standard normal distribution, once we standardize everything. Okay. I don't think that question changes. In a normal distribution, a data value located 1 standard deviations below the mean has a standard score of, you got it. This is not difficult, but it's when you overthink it, you think it can't be that easy, but it is. If we're below the mean, we are negative in our standard scores. And if we're above the mean, we're positive. So it's, yeah, they did give us the answer. It's 1. But because we're below, it's negative 1. In a normal distribution, a data value located 2.1 standard deviations above the mean, that's 2.1, positive 2.1. And you're going, that seems too easy, but it is what exactly it is. Okay. A standard score is a measure of how many standard deviations. In a normal distribution, the mean has a standard score 0. Okay. So they ask you these many times, and it's just, it is, because that's what they do. Okay. They made a formula where that's how it works. That's all there is to it. And then once you understand those, the rest of the questions kind of fall into place. These have us calculating some standard scores, so this we'll do a few of these, especially these at the end, because what I'm going to do is we'll do the algebra. These ones that they give us a z-score, they want us to get the x value. We'll do the algebra so that you actually will have 2 formulas, so you don't have to do the algebra each time. Okay, so for the top ones, let's see, what's our formula? What's a good, let's see, our formula is going to be, when we want to calculate the z-score, it's going to be x, which is the data value, minus the mean, divided by standard deviation, which I'll just put SD, because that's standard deviation. Make up your own stuff. Again, they always, in the beginning, will give you the mean and the standard deviation. For all of these problems, that's not going to change. Okay. So the first question, we're given a data value of 20. So we take this, and we say that z is going to be equal to 20 minus the mean, which they gave us was 18. Let's do this. It's circle that in red, circle that in red. So the 18 is always going to be 18, and the 7 is always going to be 7. So you're going to take the data value minus 18 divided by 7. That's always going to be the way it is.
17.43.
-20 minus 18 is 2, then divided by 7.
20 minus 18.
I think
maybe I done.
I'll tell you what you
17
did.
instead of 7.
and this is what's going to be a problem.
You can't do it all in one.
Yeah,
swoop.
because
You have to do the addition and then
Yes.
enter, get
I
them,
do
and
20.
then divide. Okay.
subtract 18 divided by 7
7.29.
doesn't give me the right answer. I need to do 20, subtract 18, enter so that it does the calculation first, and then divide it by 7. But
I thought the calculators were smarter than this.
No,
This is getting
calculators
out
are
of
not very smart at all. They do exactly what we tell them to do, and nothing more, nothing less. So, yes.
Okay, get it.
So they, yeah, 28.5. So that is the z-score. Okay, and that's all we put in. What does that mean? It means that a score of 20 is about, what was it, 0.287. Oh, it's good up there. And they want them rounded to the nearest hundred, so that's going to be 0.29. Let's see. 0.29, because the 8 gets rounded up. So far, so good? Okay. And again, this one would be the same thing, except with a different number. You see how you get practice with these. We're going to take a z-score is going to be equal to 14 minus 18, so we can see it's going to be negative, and then divide by 7. That looks like negative 4, divided by 7. And
negative 0.57. Rounded. It's negative 0.57.
sounds about right. And that's what it is. And again, we could use that if we look it up in a table to find a percentile score or something. If we needed to, we would do that. And I think one of these will be, and actually what I'll show you is I'll show you how to get percentile scores really nicely with that calculator. Now here we've got the value of x. What value of x has a z-score of 1.43? So this is a little bit different. And what I'm going to do is I'm going to do the algebra first in general so that we have a general form for this so we don't have to keep doing it again and again and again. Let's do it here. So what I'm going to do is I'm going to take this one. There's a department meeting, so when we're finished today,
We have to jet, huh?
yeah,
Okay.
we got till 11:40. We're trying to get in here because they want to set up, but we got it for 15 more minutes. Okay, but we will. If you want to stay and work on things, I'll open up the room next door so you can still stay and work, and I'll check back in. I'm supposed to be in this meeting, but I'll check back on you. And I promise I won't forget you like I did that last time. Remember I said back in a few minutes, and it's like 2 hours. Most of you were
You
already
had a
gone.
meeting?
I did, but
All right.
I had more meetings than I thought I had. So anyway, thank you for understanding. Okay, so what we're going to do is we're going to solve this. So we're going to multiply both sides by the standard deviation.
So are we doing the same thing?
We're doing the same thing, but I'm going to show you, we're going to solve this for x. Okay,
Oh, okay. Okay, let's do it.
so you're going to get standard deviation times z. So you get standard deviation times z equals x minus the mean. And then algebra, you would add the mean to both sides, right? So we're going to get this new formula, right, where x, if we're looking for x, it's going to be equal to the mean plus the standard deviation times z. Okay, so this is just going to be an easier one. Instead of plugging it in the other calculation and then solving. Okay, so what we're going to do is we're going to start off with that x is equal to the mean minus standard deviation times z. Okay. So we come up here and we're going to say x equals, what is the mean? 18. Sorry, that's not supposed to be minus, it's supposed to be a plus. Plus, what is a standard deviation? It's 7. And then we multiply that by the z-score that they give us, 1.43. And just do order of operations. We multiply first, and then we add. Okay. So 7 times 1.43. So come up here, get my calculator, let's clear it off. 1.43 times 7 equals that, and then I add 18. So that's 28.01. So that means that a z-score of 1.43 is equivalent to 28.01 as a measurement. This is weight of potatoes. That's what the potato weighed, how many ounces, or whatever it is.
I guess I missed something. I'm just trying to. So you start out with the SD times Z equals X minus mean. Then your next step that's the formula.
Yeah, and then
okay, so how do I get that? Because I know there's a Z on one side and an X on the other side.
Right.
So I'm stumped right now.
Okay, so then what I did.
Sorry.
It's okay. What I did was I added the mean to both sides.
Oh, okay, because that's
that
the
goes
algebra.
away,
Because I forget algebra. I really
Yeah.
don't.
So I was,
So
if
plus
you,
18. I remember now. Okay.
so now what I've done is I've given you a formula, and this is what they do in statistics. They give you a lot of formulas where you either memorize them or write them down on a sheet so that you don't have to do algebra to do the different calculations. You just, well, if I'm looking for x, I use this formula. Now I don't have to do algebra. Does that make sense?
It does.
Okay, so with this formula, I plug the mean, I add the standard deviation times the z-score, and now I just know my calculations over here. Multiply and add.
How did we get the z-score? I mean, we calculated the z-score.
Oh, they
it
gave
gives
us the z-score. So that's
okay.
yeah. So the hardest part is sometimes they just give us stuff.
Oh, I could have plugged that in then instead of doing
Right.
the z-score.
Yes.
I could have plugged the z-score in and just worked from that
Yeah.
formula.
Exactly. So
7
when they
times
give us the
1.43
z-score and they want to find the x, we just use this formula. So we don't have to go through these steps.
I see what you did, and then okay.
So it came
All
up
right,
with
thank you.
Yeah. So we've got this new formula,
Okay.
and by having these two down, you'll be fine. Okay. When you take the final exam, I'll have a little note sheet with that on there, so that you don't have to memorize it. Yeah, everybody wants to get in here early. Okay, so we'll make sure we're done in a few minutes. And so again, there's just more calculations. So far, so good. I want to show you. I think the next one, this 10.1, I think is where we're going to use the calculator.
Would 0 be the same thing?
What was the
Would you plug in 0 like you would the decimals?
Yes.
Okay.
Yes.
what was the answer to that? X equals.
Oops, it's gone.
Yeah, it does that one.
I think it was. Oh,
But
it's up
it's
here.
18
28. I got 28.01. Yeah, 18 plus 7 times 1.43. So you have to do the multiplied part first, and then add the 18. You get about 28.01 because this is almost 10.
Because it's 25, 18 plus 7.
No, 7 times 1.43 first.
Oh, you got to do the multiplication first.
Do the multiplication first, and then add the 18.
Okay, I get it. Okay, so I should have put that. Oh. That's all. This is exactly what I forget. It's been.
Yeah, it's just,
I forget.
It's the simple parts that are the hard part. That's why, yeah, it is. It's always been that way with math.
Okay.
I think this is pretty much, you'll set it up just like before. See, 47 z-scores. I think you can handle that one. Let's look at this one. This is the one where the calculator is going to be very helpful. And I'll show you how to use the calculator. Okay, so the online calculator will show it to us. So we've got the weights of a certain dog breed are approximately normally distributed with a mean of 52 pounds, so we're going to be using that, and a standard deviation of 6.4 pounds. Use your graphing calculator, or in this case, the online calculator, which is going to be easier to use, To answer the following questions, write your answers in percent form, rounded your answers to the nearest tenth of a percent. So we'll handle all that. Find the percentage of dogs of this breed that weigh less than 52 pounds. Okay. So these are ones where we're going to be able to use the calculator. What we just have to remember, well, actually, you could probably do this one, but I'll show you. How can anyone answer that? What percent weigh less than 52 pounds?
48.
There's
What percent?
the
weigh
mean
less
is
than 52.
50%, because the mean is 52 pounds. So 52% or 50% should be below the mean. Does that make sense? The mean is 52. What percent weigh less than 52 should be
52%? Why would it be
50%.
52% then?
Don't-
Or 51?
half, because remember, always half or 50% lie below the mean. So don't get
Oh,
thrown off
okay,
by the
okay.
numbers.
5% of the dogs.
What I'm going to do is I'm going to
less
show
than
you
52 pounds. Okay, okay.
with the calculator.
Yep,
Where is it?
please
Not there.
do. 'Cause,
Okay, so in here, let's clear off the screen. So in this calculator, make it a little bit bigger. There's a place to put the mean. I'll put that in there, 52. There's a place to put the standard deviation. Does anyone remember what that was?
6.4.
6.4. There it is. Look back. 6.4.
Oh, I went crazy on you.
6.4. Now we want the percent below 52 pounds, right?
Yeah.
So what we do is we click on the below, and we replace this 1.96 with the data value of 52. And then we hit calculate, and look what it does. It tells us that it's 0.5. Yes.
Okay, why is the other number still in there? Because I erased all the other numbers, and it still gave me a 0.5. But still, I took out all the numbers where there's...
Sure.
But it's only using the one that you've got the dot on, that's why. Okay, got it.
So you can
Okay.
ignore all the others.
Okay.
But this is the part I wanted you to see as it draws the graph. You can see the 50% below, right? You can see the data value of 52 is the mean, and it's even got it laid out for you here. So you could even use this for some of the other ones if you wanted to, and just copy these values. Notice it's got 1 standard deviation above, 2, 3. So it lays it all out for you.
I see.
Where it's really going to be helpful, though, is in these other problems. So, okay, I put in my 50% by multiplying by 100. Find the percent of dog breeds that weigh less than 49 pounds. I just come back here. So below, less is below. I change the 52 to 49. And I click recalculate, and I can see it's moved down a little bit. And it gives me what is that, 0.31.
3196.
96, so round it to the nearest tenth of a percent. It's going to be 31 point. Actually, it's going to be 32.0%, right? Take
Oh, yes,
yeah,
yes.
0.3196 multiply by 100. Moves the decimal over 2 places.
It's
And one up to the
32%.
nearest, so it's going to be 32%, and actually 32.0%. Find the percentage of dogs in this breed that weigh more than 49. Now you could also just take that number and subtract it from 100, which would give us 68%. Or we just come back and say percent above, and then we put the 49 in there. And then we click on recalculate, and we've got 68.04, which is pretty close to 64 or 68%, right? So this calculator
It's
is
magnificent.
like worth its weight in gold. Actually more, because it doesn't weigh anything, but it's a great thing. And then we can hit submit, and you got it all right. You'll see that 10 is a very similar type question, and and you get into homework, there's more of these. All you have to do is enter in the mean, the standard deviation, and again, these are getting into sort of what I call nasty numbers. They're not easy to work with. They're not nice round numbers. They got decimals. 41.8 and this one down here, look at this. Let's go ahead and do one of these. It's between 38 and 43. And again, they're not necessarily one standard deviation above or below. So let's put this one in 41.8. And again, we just come back. We put in a new mean. 41.8. What was the standard deviation? Anyone remember?
Oh, I don't.
Me neither. 55.2. But this is the part you have to get the numbers right. And then I'm just going to jump to the last question because that was kind of complicated. What percent of years will have an annual rainfall between 38 and 43 inches? So I'd go for between. This is just a real powerful. I wish I would have had this when I was learning stats.
Well, yeah, but
38.
You wouldn't know as much now.
Yeah, I'd still be a child. What was it? 38 to 42? I think that's what it was. And then just hit recalculate, and it gives you the sliver. You can even see the picture. This, when I was learning, I had to draw this all by hand. I'd have to use that z-score calculation, get these z-scores. I'd have to go look up the percentages in the table. I'd get two percentages, and I'd have to remember whether to add them or subtract them or something. Now with this technology, with the internet, without having access to all this stuff, we just enter it in, we get it. But doesn't this help you understand it better? Because you can see the picture. You don't have to. It took me years to figure out to draw the picture. Now we just give it to you, but it's going to help you understand it faster too. That's why I say we're changing the normal curve distribution of learning because we've got better tools. We can experience something first. Is really the way education should do it. You should experience it first and then do it, instead of trying to learn it and then somewhere along the way, 5 years later, finally learning something that was so simple that we could have done in 5 minutes, but our methods were good. So again, we got other people. We got 1 minute left, but that's 12. It's with all of the stuff. So we went through pretty much all the practice problems. You'll be good with those, the reading quiz, and you'll see the homework problems are not too much different. Take a look at them. Remember, if you have some struggles with something, if you send me a message through MAT141, so like on this one, you can message an instructor. But please put something. I got some people who will send me a message and I say, well, what do you want me to do with this?
Right.
I can talk about it in class, but if you want, say, I'm not really sure, could you explain this? I'll be happy to do it in a video, or I'll be happy to say, I've already got a video, go take a look at this, or in the book. But just tell me, if you're completely stuck, I don't know what to do with this, that's fine. I can deal with that. Or if there's just a part of it, because I've done sometimes where I'll do the whole explanation, they say, oh, it's just the last part I didn't understand. Oh, it's negative, okay, whatever. So but send it to me. I'll do a video. I'll send you a link to the video personally, but then I'll also post it in class, so it's also helping others. So, because if you have a question, probably other people in the class are having a very similar question. So if I can do those videos, I can just post them, and we can do this sort of 24 hours a day office hours. Again, I might not get back to you in 5 minutes, but maybe I will. So sometimes, yeah, I'm working late at night. It's 10 o'clock, sometimes 2 in the morning. I can't sleep, so I'm up working. I see a thing, I'll make a video. I got my room is set up where I got the cameras, I got everything ready to go. I got my little tablet set up. I said, okay, let me just whip something out. It's getting easier and easier. And again, I'm here for your success. So I want you to be successful. I want you to learn. And I want you to not spend 10 hours stuck on something that we could have rectified in 1 or 2 minutes. So email me. If I don't get right back to you, go do something else. When I do reply, I'll have a nice explanation that will hopefully be very understandable. Keep up the good progress, and let's have a good weekend. And a couple more weeks, we get a spring break. Awesome.
I want to be at the end of school.
Oh,
Good job.
what should we have for your word of the day?
Meetings.
Meetings. Okay. Department meetings, every kind of meeting. So,
Yep.
meetings. Word of the day. Thank you.
I do want to go next door. I don't know. If
Okay,
anyone else
yes.
does.
It should actually still be open because
Oh,
I have
great.
another student
Okay.
taking the test. So if you go just right next door, it's the same setup. Go
Perfect.
ahead and log in and.
I gotta go take care of a couple things in the morning.
So now stop streaming.